Welcome to Lecture Online. Whenever we have equations of two variables, and here's the example again, y equals x plus 4, y being the dependent variable, x being the independent variable, or writing it where y is a function of x, which is equal to x plus 4. Whenever we want to represent the solution to an equation like that, we can do so with ordered pairs. So what do we mean by ordered pairs? Well, here we are evaluating the equation for three different values for x. Y when x equals 2 is equal to 6, y when x equals 3 is equal to 7, and y when x equals 4 is equal to 8. We find those values by simply replacing x by those values. X, instead of x, we write 2, instead of x, we write 3, instead of x, we write 4. And that's how we evaluate it. So we can represent those solutions by an ordered pair as follows. Here we can write the number for x, which is 2, and then the number for y, which is 6. So the first number represents the value for x, and the second number represents the corresponding value for y, because this value depends upon what we gave to this value. Here we can have an ordered pair where x is equal to 3 and y is equal to 7, and here we can have the ordered pair where x equals 4 and therefore y equals 8, and so forth. So you can see that you can represent the solution to this equation for plugging in particular values for x and getting corresponding values for y. We can also draw those ordered pairs on what we call the xy coordinate system or the Cartesian coordinate system. So we draw two lines, a horizontal line representing the x-axis, and we draw a vertical line representing the y-axis. And these points are somewhere on this plane. The first point represents the value for x. So just like a number line, we can draw the point 1, 4, 2, 5, 6 in the positive direction, and -1, -3, and so forth in the negative direction. Then we can draw values on the y-axis. Here we have 1, 5, 2, 6, 3. Make the number line a little bit longer here. Here we go, 7, 8, 9, and so forth. And then, of course, the negative values, -3, and so forth in the negative direction. So to find the values for the ordered pair on the xy coordinate system, we first find the number 2, which is right here, 1, 2. And then we find the number 6 on the y-axis, 1, 2, 3, 4, 5, 6. So when we draw a horizontal line over here, and we draw a vertical line over here, where the two meet, that's where we have the ordered pair 2, 6. We can do the same for 3 and 7. We draw a vertical line straight up like this, and we draw a horizontal line for number 7 where the two meet. That's where we have the ordered pair 3 and 7, and we can do it again for 4 and 8. Draw the vertical line, the number 4 this way, and a horizontal line number 8 where the two meet. That's where we have the ordered pair 4 and 8. So you can see that those pairs of points, or I should say those points with the ordered pairs 2, 6, 3, 7, and 4, 8, you can see they all lie on a straight line. We can actually connect those like this. And notice now, I'm a little bit off here, but notice now that this line represents a solution to this equation, y equals x plus 4. Particular value for x will have a particular value for y. The value of y depends upon the particular value for x. And again, notice we can have ordered pairs representing solution when you put ordered pairs on an xy coordinate system like that, and you connect those dots representing those ordered pairs, you end up with a straight line, and that's by definition why this is called a linear equation, because when you put the ordered pairs on the xy coordinate system, you end up with a straight line. And that's what we mean by ordered pairs representing an equation in two variables. And that's how it's done.